So I work at I work with Terraform at Instacart. I actually started at Instacart 4.5 years ago, on one of the development teams, and our entire infrastructure team is actually composed of former developers. And so I've been really interested in some of the talks about Terraform from a developer's point of view, because we're really, in part, we're using it to make sure that the developers can do what they want. So I joined the infrastructure team about 2 years ago, and since then, we have terraformed about 15,000 AWS resources, among which are about 80 RDS instances. And I actually started, I think that my title on this talk was 50 instances when I applied for speaking a couple months ago. So it's growing really fast. And not only our RDS instances, but everything that we have terraformed. One of the things we're doing is trying to enable the developers to also use Terraform, just to make it possible to manage all of these things with our team. Unfortunately, when I joined the team, we were all new to Terraform, and I copied a lot of the previous people's mistakes. So some of the issues that I'm going to talk about have as much to do with the fact that we were inexperienced in using Terraform as they do with Terraform being somewhat complicated to use with our RDS. So here we go. I'm going to go very briefly over what Terraform is. A lot of people have already touched on that. Plus, y'all are here, so hopefully you know. I'll do a little bit more about RDS. Then I'll talk about why putting the two of them together really, really sucks. And I think I can say this even now with 2 years experience behind me, it still sucks to try to manage these together. And then finally, I'll go over why I highly recommend doing it anyway, because well, y'all have seen that in previous things, but basically I do love Terraform. So what is RDS? RDS is a service offered by AWS, which is basically an abstraction over running a Postgres server. And the abstraction in particular means that you don't really get a look at the hardware. You don't get to recompile the Postgres software if you want to add extensions or make some changes. You basically have available whatever AWS offers to you. And the same is true for any sort of logs. You only have what AWS provides to you. So rather than, when you were managing it yourself, you'd be able to look at everything and rebuild and reconfigure as you please. AWS takes care of that. And that's both good and bad. I mean, as someone who would have to do that management otherwise, since I'm on the infrastructure team, I kind of like the fact that AWS takes care of it. AWS adds an additional abstraction. If y'all are familiar with configuring databases, or really with configuring anything, there's usually a configuration file, and you stick a bunch of values into that configuration file, and then when the service starts up, it reads the file, it gets those values, and that changes the way that the service works. AWS handles this by using what they call a parameter group, and that's just really just a list of key value pairs which get applied to the server on startup and also dynamically. So some of the parameters can be set, like if you connected to your RDS instance, you would be able to just set them right there in SQL, or you could set them on the command line. Others have to be set when you actually start the instance. So AWS marks these in the parameter group as either dynamic or static parameters, and that will come up later. It's one of the things that really hurts or can really hurt. Then Terraform, of course, is yet another abstraction layer. So it's a very thin abstraction and not at all agnostic. So if we configure an AWS database instance, that's not going to be the same as if we configured a database instance in another cloud. But the good thing is that even so, once you've written it down as a configuration, it's fairly easy if you wanted to port it to another provider. But still, it's hiding some of the detail of what's going on. And then if you include modules, you add some more layers of abstraction. And modules are actually one of my favorite things about Terraform, because they really allow us to treat it as code. And as a former developer, I'm all in favor of the dry principle and creating functions, creating methods, whatever language I happen to be using. So a module is the equivalent of creating a reusable function. And it's great, but at the same time, again, it hides a lot of detail. So I've mentioned abstraction a few times, and abstraction is where a lot of the pain comes in. There's an old fairy tale called The Princess and the Pea, and in the fairy tale, they're trying to locate a true princess, and so they pile dozens of mattresses up, and they stick a single little pea somewhere in the stack, and then they're testing the princesses, and this one just cannot sleep at all night because of this one little pea that's irritating her through these piles of mattresses. And I think that the abstraction is very much like that, that there can be a tiny, really, I mean, it doesn't have to be a really big error somewhere in this big stack of abstraction. And that's going to percolate up through all of the abstractions and cause trouble for you. And each of these layers, and that's what I'm going to be talking about in this talk, each of these layers has areas where there's little difficulties can creep in. And then you have to deduce, based on perhaps very incomplete knowledge of where all of this is coming from, where the problem is. Okay, so the first thing is I talked about RDS as an abstraction. So RDS and Terraform itself, the AWS provider, provide defaults. So if we look at the configuration on the left, we're creating a new database here, and we've specified some of these variables. If we look at the plan on the right, and I've abbreviated this because it actually has about 30 to 40 elements in it, you're going to get a bunch of things which are marked as known after apply because you're creating a new instance. And those are coming from AWS defaults. So AWS is going to just set something there for you. And unless you're really familiar with AWS and RDS, you may not know what it's going to be set to. In addition, the Terraform provider sets a few defaults too. And there's nothing wrong with the defaults it sets. It's just that if it isn't what you want, you won't necessarily notice in this gigantic stack of values that are being set that maybe a value was not set the way you want it to be. So you have to read these plans very carefully. So then if we go ahead and apply that, you can either look in the AWS console, or you can go ahead and look in Terraform State's show, which I love. And I especially like version 12 now, where it shows it very much in a format that you could cut and paste back into your config. You don't really need to read through all of this, but I've just highlighted in orange the things that got set by AWS, and in purple the things that got set by the Terraform provider. And so you notice that the things that I actually set are a very small portion of everything that got set in here. And I could have set more, but I can go ahead and create a database without doing that. And that's great, but it also means that there are all these values that get set, and I don't know necessarily where they came from or why. So now we get to the next thing that the AWS abstraction can cause trouble with, and that is this option to apply immediately. So this is actually really important, because if you apply certain changes to your database, you're going to have to restart it. And if you've got millions of requests coming in from your customers and your website's completely dependent on your database, and it just goes away for, you know, a few minutes even, everything goes to hell, right? So you don't want to apply these things in the middle of the day when you're actually working. You want to apply them at night when maybe very little is happening. And actually the way that I got onto the infrastructure team originally was that we were having problems with our database where we needed to try to migrate it to a larger, it was growing very, very fast. We needed to try to find a way to migrate it to a larger instance, or maybe partition it into other databases. And so I pretty much became really nighttime person, like totally taking on the night shift and working from maybe 10 p.m. to 4 a.m. every day, because we're a grocery shopping delivery business. Things are actually really quiet at night. You know, we cover the time zones in the United States. And then after about 10 p.m. Pacific, happily I am in the Pacific time zone, very little happens. And so you can go ahead and reboot your databases and make massive changes to them, and mostly people won't notice. So apply immediately. Originally, when I created the module for this, I set it to false because I thought, yeah, we don't want to apply these changes right away. Just in case it reboots the database, we want to make sure that they're applied at night when we've actually set a maintenance window and we've intended to apply them. The problem is that, as I said earlier, we want our developers to work on this too. So a developer would come in and they'd be like, oh, we're running out of storage on this database. I'll go ahead and increase it from 100 gigabytes to 16,000 gigabytes, and we'll be good. And then later they'll come back and they'll be like, why are we still running out of space on the database? And it's because apply immediately was set to false. And they would go ahead and plan and apply, and Terraform would say, hey, it's great. I've applied complete, yay. you will notice that it took only 32 seconds. Now, if you go ahead and set, let me go back. If you go ahead and set apply immediately to true, then you're going to find that this takes more like 30 minutes because we are increasing the storage tremendously. But again, the developers being also another layer of abstraction is from like developers to infrastructure. We don't necessarily tell them everything that we know. So they'd be like, oh yeah, I increased the space, and they really didn't. And then maybe they might even come back and plan again, and they would still see a difference. They'd be like, well, you know, where'd this difference come from? Because I applied it. Recently I actually made the change to have the module set apply immediately to true because our database team decided that it was better that the changes actually happened when we thought they happened when we did the apply. But now we have to make sure on every time that someone tries to make these changes, we're like, hey, wait, no, don't do that at noon. Wait until tonight to do that apply. Okay, so then we have a very similar thing. I feel like I've skipped one. Yes. So now we have this abstraction layer of the parameter groups. And again, this works really well when it works, but there are things that can happen that are very unexpected. So for example, we're upgrading our databases from an old version of Postgres to a newer version of Postgres. And we go ahead and we change the parameter group family. So we say, okay, I'm not using Postgres 9.6 anymore. I'm using Postgres 11. Great. Terraform plans, great. We go ahead and do a Terraform apply. And now if we had noticed in the plan, it says, oh, I need to replace this because you're making a breaking change. So, okay, great. You're going to delete the old one and apply the new one. I don't mind because I know that the parameter group got applied in AWS when the server started up. And so if I make change to the parameter group, which is a distinct resource in AWS, that really doesn't affect the database. At least that's how I'm thinking about it, right? But then I go and it says, well, you can't delete this parameter group because it's in use. I'm like, well, it's in use, yeah, but you already used it. Like you already started the database up. So why is this a problem? So now it's maybe taken me, you know, several minutes doing the plan and apply, and then it says, oh, you can't do this. Now I have to go back and either modify the database in the console to detach that parameter group, or maybe make an entirely new parameter group, then make a new plan and apply to attach the new parameter group to the database. This is actually protecting you, as it turns out, because it's not that easy to update the version of RDS, but it's just the insulation from these changes that makes it do things that are really unexpected. Even more so now, within the parameter group, I talked about the difference between a parameter which is static, which has to be set at the time that you start up the server, and a parameter which is dynamic, which can be set anytime. And it'll just go ahead and set that on the database, and everything will keep running the way it is. So in this case, I have a parameter group, and I have one parameter which is immediate, and that means it's dynamic. It can be applied right away. I have another one with an applied method of pending reboot, which means that I would actually have to reboot the database before this value could be applied. So I can go ahead and change that to apply immediately, and Terraform is not going to complain. Terraform is non-judgmental about this. So it's going to be like, okay, yeah, fine. If you say immediate, I'll do immediate. But then when I go to apply, what's going to happen? So keep doing this. Keep going too fast. So when I go to apply, if I have changed a pending reboot parameter to an immediate parameter, it's going to give me an error from AWS. So AWS is going to say, I'm sorry, you can't apply that immediately because this is not a dynamic value. On the other hand, if I were to change the immediate one to a pending reboot, and then I plan and apply, what happens there? Actually, it's fine. Terraform goes ahead, I do my plan, it's fine. I do my apply, it's fine. Then if I go look in the AWS console, normally if you have set a pending reboot parameter, if you look in the configuration of the database in the AWS console, what you'll see is it says, oh, awaiting reboot, pending reboot on the parameter group, because it knows that you've made this change that has to be applied on a reboot. If you apply a dynamic parameter, then it will you'll briefly see applying, and it will say in sync. So we're looking at this and we're saying, okay, I told it, don't do that, don't make that change until a reboot if I had set the apply method to pending reboot. But it goes ahead and applies it anyway because it knows that it's actually an immediate parameter. It can be set right away. So maybe that's good, but maybe that's confusing because I've said, I thought I said in the parameter group, oh, I don't want to apply this until the system's rebooted. And yet what actually happened was that it got applied and nothing in Terraform or in the AWS provider told me that that was going to happen. So a little aside on plans. Parameter group plans are probably the worst plans in Terraform. Close or possibly a close second actually to planning IAM. My brain just left me. Any IAM resources, but especially policies. So you're basically playing a game of find the differences between these two pictures, because when it talks about, when it shows you the plan, it's going to show you for any parameter that you're changing, that it is deleting the parameter and then that it is adding the parameter again with a different value. And if you just have like these two parameters, that's fine because it's pretty small, you can see, and most likely they'll show up next to each other. But if you have 15, 20 parameters reset, which is not uncommon, there are hundreds of them potentially, then the deletion will be here, and then the add will be down here. And so you're going to have to be scanning back and forth or having some sort of editor or something that will sort these parameters to show you what the differences are. And I actually wrote like a little shell and grep thing that showed me parameters next to each other, just so that I could see, are the differences really what I want them to be? So this is something I think Terraform could probably improve on, but it also could be the AWS provider. I'm actually not sure which one is causing the pain there. So okay, all those things are like moderately painful and things that you have to remember or be familiar with, or you'll get an error message, or maybe you won't get an error message, but nothing really bad will happen. But something really bad did happen to us. So there was some real pain involved. And this is when we were upgrading from Postgres 9.6 to Postgres 10. So we took our Terraform and we changed the family for the parameter group. We made entirely new parameter groups using the family Postgres 10. Then we went and we changed the version of the database, and we waited until nighttime so that we could do the upgrade. And we started doing the upgrade, and it goes great. Actually, it goes really well. Now we're upgraded. Yay, we're on RDS 10, RDS with Postgres 10. But then we started getting these CPU spikes, and CPU kept spiking and spiking. And we were trying desperately to figure out, like all hands on deck, everybody trying to figure out what was going on, because when our database is not responding, then our website is not responding, our shoppers are not able to shop, our customers are not able to place orders. So we said, all right, what's going on here? And it took, I would say, close to a week before we finally tracked down the problem. And in the process, we said, well, you know what? We've got this in Terraform. This is great. We can just go back in our GitHub repo and find the exact definition of the parameter group and set it back to exactly what it was in 9.6. Because, of course, when we upgraded to 10, we made a few improvements, because you always make a few improvements. So we're like, yeah, we'll change it back. We'll have it precisely what it was before. And then we'll know if the problem is in the parameter group or somewhere else. So we changed it back, did not improve at all. So what was going on? Eventually, it occurred to me, the parameter group is an abstraction. We can actually look directly into the database and see what's going on in the database. So we looked into the database. And when we applied the identical parameter group to Postgres 9.6, we see this. We have this parameter max wall size. I actually diffed like dozens of parameters by hand doing this, but this is the smoking gun. So we found that max wall size was set to 128, which was the value in the parameter group, 128. And the units were 16 megabytes. So our max wall size was 2 gigabytes. And this is about what we wanted it to be, because that means that we get a database checkpoint every 5 to 10 minutes, depending on how busy the database is. Then we applied the same thing to Postgres 10. We took a look in the database, and it says 128, so it's still set to the value 128, just like the parameter group said. But the units are now megabytes. And so that means that instead, oh, I see an editing error in my slide, 128 megabytes. So from 2 gigabytes down to 128 megabytes. So we're actually checkpointing 16 times more frequently than we mean to. So several times a minute instead of every several minutes. And of course, that caused the CPU to spike because there's a lot of disk I/O going on with the checkpoints. And also it meant that the database was somewhat unresponsive when it was doing these checkpoints. So we updated the value to 2 gigabytes instead of 128 megabytes, and our problems went away. And we looked in the AWS documentation. We said, did anything mention that down at the AWS parameter group layer, they were changing the units of this parameter from 16 megabytes to 1 megabyte? And nothing mentioned that at all. So we put in a ticket to AWS and we're like, hey, your documentation's wrong. And they're like, oh yeah, thanks so much for finding that. We'll get that fixed in the next month or so. And we're like, oh God, really? Okay, so so modules. So there have been, I actually watched a couple talks earlier, and there were some good talks on modules. With parameter groups in particular, I've actually come to the notion that I don't think it's a good idea to use modules. And as much as I love modules, especially as a developer, and I want to do, the don't repeat yourself and hiding implementation details and all the good things you can do with modules. Problem with parameter groups is that they're just weird. They're all defined with the parameter blocks rather than with like individual variables. And so our first iteration of this, which I think we were still Terraform 11, but it was a couple of years ago, we actually specified every single parameter that you could possibly specify, and we had a variable with a default, and then we set those in the parameter group configuration inside the module. And what that meant was that we ended up officially setting a lot of values that we didn't really mean to set. It's just that we didn't have the option of maybe setting the value, which we do have now in Terraform 12. So I went back and I'm like, okay, now that we've got Terraform 12, I'll make a better module. I'll make a module where parameters are set conditionally. But then we still run into the problem that we're running many different versions of RDS. So we span anywhere from RDS 9.4 to RDS 12, which is the latest version. And so given that, each one of those versions had different sets of parameters that were available. So the module got more complicated because I had to allow for different versions of the database with different parameters, and as we've seen, with potentially different units. So I put some computations in, and I put some documentation in the module saying, oh yeah, this is now 16 megabyte units instead of 1 megabyte units, and this depends on the type of instance that you're running. So you're going to want to increase this value if you're running a larger instance for your database. And then we want to put in some alerts. So we want to use CloudWatch, and we want to say, okay, when we're within a certain level before we run out of space, we want to alert. But some databases are very small, some databases are much larger, and the alert is based on an absolute value. So we have it set to 500 gigabytes, and for a database that isn't even 500 gigabytes large, it would just alert all the time. So we started to back off on using modules, and particularly for parameter groups. We are still using a module for RDS instances, and I think we can write a good one for parameter groups, but I think we just have to put a lot of thought into it. The RDS instance module, I've now spent probably one of the last 2 months updating the versions of that as we've reversioned to make a better module. So we've added we are using Datadog, so we've added Datadog monitors. We're making changes to the way that we handle security groups. So we put the building of the security group into the module. And each time we change the module, we have to go back through our code base. And as I said at the beginning, we've got about 80 RDS instances being managed here. So I've got to update 80 different versions, and I've got to do the imports or make sure that the diffs are correct. So if I was going to do it again, I would definitely sit down and design the module beforehand and not just allow it to evolve. Just because RDS is such a complicated thing. Like for other things, I've been able to write modules and let them evolve, and they haven't been nearly so painful. But RDS has all of these additional layers. Also, the first version of the module I wrote, and this is something that I will absolutely never do again, it had modules which reference modules which reference modules. So it added multiple layers of abstraction, which I've already talked about as being problematic, and they weren't worth it. You know, it was really just my coder brain saying, oh, well, you know, you break it down into smaller and smaller functions, and each function calls other functions. But in the case of Terraform, I think a little bit of cut and paste is better, because it really reveals to people what's going on. And sometimes you need to change what's going on at one of those levels. And by having that all hidden from you by multiple layers of modules, you really get to a point where it just becomes completely unmanageable, and from the point of view of a user, really difficult to use. They don't know why they're setting these values. They don't know why some values are required and some aren't. If the values aren't required, they don't know if they should be setting them. So we've backed off a lot on that. And I think once we are really comfortable with what we've got, we will probably go back and recreate those modules one more time. But I think that we would have been better served to terraform the resources first and worry about the modules later. I said at the beginning, I still recommend doing this. There have actually been some good talks previously about why infrastructure as code is a good idea, but I'll reiterate, especially if you've got a team that's come from a developer background, we really like this. And if you're allowing developers to use it, we like that it's in GitHub. We like that we have code reviews, that you can make changes, and you can also revert changes through this process of using Terraform and using GitHub, rather than going into the AWS console and you make some changes and then you're like, oh, well, I don't even know what that value was before. So now you have to go search through AWS's CloudTrail, which may or may not tell you what the value used to be and when it was changed and who changed it. So for all of these reasons, and you can look up infrastructure as code, you can look up why source control is a good thing. I don't think I have to go into all of that, but it has made a huge difference to us. And the biggest difference it's made for Instacart is that we're trying to replicate our production environment into a staging environment. So many places where I've worked, the staging environment honestly was inadequate. It was a barely related in any way to what was going on in production. And what we want to do here is provide an environment for developers which is almost identical to production. It's going to have smaller instances. Some services aren't going to be present perhaps, but all services have the ability to be spun up really easily. And Terraform has made that super easy for us, because we just make a new workspace, we make a new configuration for the new environment, we spin up the same resources. We were actually able to tear down and rebuild our developer environment in, I think there were 4 of us working on it in one morning. So that's huge. Like, there's no way that we could do that with thousands of resources in AWS console. So Terraform, absolutely. I mean, you probably already agree with me because you're here, but it has been life-changing for us. RDS, some people on my team, or actually on the Postgres working group team, are arguing that we should self-host. As a person who would have to make sure that minor version upgrades happened and backups happened and maintenance windows were respected and all that, I prefer RDS. I'd rather have AWS handle it. But you really do have to deal with the fact that all these layers of abstraction are going to cause a lot of trouble for you. And then I think beyond that, a lot of it is just really knowing what you're doing. It's so easy to cut and paste. And I see our developers over and over again cutting and pasting. And maybe they're cutting and pasting a good configuration, and maybe they're cutting and pasting a bad configuration, and they don't know. And honestly, people on my team don't necessarily know either, and we're the ones who are supposed to understand the infrastructure. So Terraform makes it particularly easy to do that cut and paste, which I would say is both good and bad, but it just means you have to be really careful when you're reviewing your plans, when you're approving changes in GitHub. We use Atlantis, which allows us to review the plans and prevent apply until somebody's reviewed the plan in GitHub, and that's been very helpful. So yeah, absolutely do it. And also be like very, very careful. So that's me, Muffy Barkocy, also on Twitter, though I don't actually show up on Twitter very often. But I'm also the only Muffy Barkocy in the world. So if you want to find me, I'm easy to find on pretty much any social media. And I'll take a look for questions in Zoom.